Hello class, welcome to this video on AP Statistics, Chapter 8, Lesson 2, Estimating a Population Proportion. So how do we use confidence intervals to estimate population proportions? That's what we want to address today. So our first learning target is to state and check the random 10% and large counts conditions in order to construct a confidence interval for a population proportion. So recall that confidence intervals, what we use them for is to estimate unknown parameters. And parameters are based off of the population. So unknown population parameters. If we go back to the beads activity or the beads example, there was a large population of beads. We don't know how many there were, but we did take a random sample of 251 beads from that population, and we found that we had 107 red beads and 144 of other colors. And so we constructed a confidence interval to be able to estimate the true value of proportion of red beads in that population of beads. And we calculated using the point estimate plus or minus the margin of error. And we said that the margin of error consisted of two components, right? The critical value and the standard error. And the point estimate is just a statistic that we use from our sample. So let's look at the statistic part of it first. So we decided to use p hat as a statistic, right? That was, we decided to use that because p hat is an unbiased estimator of p. What do we mean by unbiased? Unbiased, again, means that the average of the statistic that we use is equal to the value of the parameter that we're trying to estimate. So in other words, the average of p hat, the sampling distribution of p hat, is equal to the parameter we want to estimate, which is p. All right, that's what we mean by unbiased, and that's why we use p hat as a good point estimate. All right, now critical value. We decided to use a critical value of 2 based on the empirical rule because it was the 68, 95, 99.7 rule, and this is for plus or minus 1 standard deviation. This is for plus or minus 2 standard deviations. And this is plus or minus 3 standard deviations. And we wanted to go 2 standard deviations for 95%, so that's why we used 2, okay? And then the standard deviation of the statistic, also known as the standard error, okay? So we're going to define what the standard error is here. Remember that the standard deviation of the sampling distribution of p hat is sigma p hat. And to calculate that, we, from chapter 7, we calculated that by doing p times 1 minus p over n. However, we don't know p because we're trying to estimate p using the confidence interval. So obviously we can't use p. So therefore we have to use p hat instead of p. Now when we use p hat, this no longer becomes the standard deviation of the sampling distribution. It becomes the standard error. The standard error is the standard deviation of the statistic. And so this becomes S p hat. And so now this becomes square root of p hat 1 minus p hat over n. So we use p hat instead of p, which looks the same, but again, we used a point estimator instead of the actual parameter, the true parameter p. And so that's what we got. Okay. So then if we did that for this particular example, we said that p hat was equal to 0.426 for the red beads. So we did that. We did 1 minus that over 251 beads. And that gives us about 0.031. All right. And then, of course, we double that to get the 95% confidence, doubling that using the 2 for the empirical rule to get 95%. And then we get our margin of error. Okay. So now, again, let's define the standard error. Okay. Formally, the standard error is the standard deviation of a statistic estimated from your sample data, right? Now, the class, so in this case, the class's 95% confidence interval is as follows. Again, the structure is p hat plus or minus 2 s p hat. So we get 0.426 was the p hat plus or minus 2 times the standard error, which we calculated earlier in the previous thing. We get 0.426 plus or minus the margin of error, which is 0.062. And then if I subtract 0.062 from 0.426, I get 0.364. If I add them together, I get 0.488. And that's my 95% confidence interval. So if I want to interpret that, then we would say that we're 95% confident that this interval captures the true proportion of red beads in the container. Okay? So this is just the overall of what we did and what we introduced and formalizing the definitions. Okay? So let's generalize. What's the general formula for any one sample Z interval? Okay? So again, this is a one prop Z interval. Okay? This is important because we're doing, this is also known as a one sample Z interval for a proper proportion. We call it one prop Z int in the calculator. So when we use the TI 84, it's called a one prop Z int. All right. All right. So if we want to calculate that, this is the generic formula: P hat plus or minus Z star. Now the Z star is the critical value. Remember that we got 2 for the critical value for a 95% confidence interval. But again, if I don't have 95% confidence, I want to have something else, then I have to use the Z-score. And then this is the standard error, right? And of course, this is my point estimate. Okay? So we're going to show you how to estimate the critical value in a second. But first, let's define the conditions. This is what the first learning target is about. There are 3 conditions we want to verify in order to be able to use the confidence interval formula and proceed with doing a confidence interval. First off, the data that we select should come from a random sample. If it does not come from a random sample, then there's no point in doing a confidence interval, because then we're going to introduce things like bias, etc. So we want to first establish the random condition is verified, which is that the data comes from a random sample. All right. We do not want it from volunteers. We do not want it from convenience samples or anything like that. Otherwise, we won't have any confidence that we have a good estimate. All right. The 10% condition is the second condition we want to satisfy. Remember, the reason why we want to use a 10% condition is it's essential for the formula for the standard deviation. Remember that formula assumes that the individual observations are independent. And in order for them to be independent, we have to select them without replacement. However, it's not possible to do that practically. And so what we have to ensure is that our sample is as small as possible while still being large enough to estimate the population. So we want a maximum cap on our sample, on the size of our sample. The cap is 10%. We do not want our observations, our sample, to be greater than 10% of the population. Okay, so as long as our sample size is less than 10% of the population, then we're good. We can proceed with the confidence interval formula. If we have a large sample, we would have to introduce a correction factor, which is outside of the scope of this course. But if you did have a large sample, you would just have to introduce a correction factor to correct for the fact that you have a larger sample. And this will be a finite population correction factor, is what they call it. But that's not something that we're concerned with in AP statistics, okay? So for number 3, we're looking at the large counts condition. We need to establish that the sampling distribution is approximately normal, and in order for that to happen, we need to have a large enough successes and enough failures to satisfy that. Okay, and so remember that in order to use we want to establish normality in order for us to be able to use the empirical rule, and in order for us to use z-scores. Okay, because z-scores and all that stuff are very important, very efficient, very useful. So we can use the normal approximation as long as this condition is satisfied. Now remember that we actually don't know P. P is unknown. So since we don't have P, we're going to replace P with P hat. Okay? So in fact, the condition actually looks like this. N times P hat is greater than 10 or equal to N times 1 minus P hat is greater than or equal to 10. And that's the set of conditions we want to use. All right, so let's look at example 1. Mr. Buckley's class wants to construct a confidence interval for P equals the true proportion of red beads in the container. Now this time they told us that the container includes 3,000 beads. So now we actually know how many there are in there. But we don't know how many are red. Recall that the class's sample of 251 beads had 107 red and 144 others. Check if the conditions for constructing a confidence interval for P are met. All right, so first off, the random condition. We took a random sample when we did this. We took a random sample of 251 beads from the container. That's how we got that result. Let's check the 10% condition now. So this checks out. 10% condition is the 251 beads less than 10% of the population. Well, what is 10% of the population? Well, the population is 3,000, the population size, so 10% of that is 300. Now, notice that the 251 beads is less than 300. And therefore, it's less than 10% of 3,000, sorry. All right, so that checks out. Large counts condition. The large counts condition, we said, okay, the sample size we took was 251. The P hat was 107 out of 251, right? So let me write that out. P hat is 107 out of 251. So if I calculate that, if I put that in, well, then notice the 251s cancel, so it leaves me 107, which makes sense. 107 successes. That's greater than 10. Now the next one is 251 times 1 minus 107 out of 251. But we know that there were 144 failures, right? So this becomes that. So cancel those out, we get 144, which is greater than 10. You could go right away and say that 107 successes is greater than 10, 104 failures greater than 10, and done. You don't have to do this n times p hat for this problem. Okay? But I did want to show you just in case. All right, go ahead and pause the video and see if you can try Latoya's example. All right, so the check, Latoya wants to estimate the proportion of the seniors at her boarding school who like cafeteria food. She interviews a simple random sample of 50 of the 175 seniors and finds 14 think the cafeteria food is good. Check if the conditions for constructing a confidence interval for P are met. So what is P hat? P hat is, well, we had we had 50 people that we selected, and 14 think that the cafeteria food is good. So 14 out of 50, right? This is the 175 is the population size, so that would be the big N. Okay, but our little n is 50. Remember that the formula for p hat is x over little n, where x is the number of successes and n is the sample size. Okay. So the random condition, it says she interviews a simple random sample. SRS means simple random sample. So she interviews a simple random sample. Okay. Now it only matters that it's random. It doesn't have to be simple random sample. Okay. But it's random. 50 seniors from her boarding school. All right, so now let's do 10% of the population. There were 175 seniors. 10% of that is 17.5. And so we see that the 50 seniors that she selected is greater than, not less than, that's a typo, is greater than 10% of all seniors. In other words, 50 is greater than 17.5, right? Or no, yeah. So there you go. So 50 is greater than that, and therefore the condition is not met. So it's not met. Now this one is met. Check on that one, but this one's not. Okay. The large counts condition. We have 50 times the p hat, which is 14 out of 50, which is 14, which is greater than 10. So that checks out. This one's 50 times 1 minus p hat, so 1 minus 14 out of 50, which is equal to 14 times 36 out of 50, which is going to be 36, which is greater than 10. So all the conditions are met except for the 10% condition. All right. So now let's look at the next part. Before we dive into the learning target 2, let's look at this part. If the random condition is violated, well, as we mentioned earlier, there's no use in constructing the confidence interval. If we have large counts condition violated, then the capture rate is almost always going to be less than the confidence level, which is not good. We don't want that. If the 10% condition is violated, then that means the formula for the standard deviation of p hat is not going to lead to the correct value. That means that the formula is going to give you too large of a value, which means that the true value is smaller than what the formula gives. The confidence interval in that case will be too wide when we calculate them, which is going to lead to a greater capture rate due to too much margin of error. So we would have the intervals being too wide, which is going to look like it has a greater capture rate because of the margin of error, when in fact the capture rate is not that big. Okay, so that's important because it's going to affect the formula, and so therefore is going to affect our perception of the capture rate, right? Of the true capture rate. All right, so learning target 2, we want to determine the critical value. So this is where I show you how to calculate critical value using table or technology. All right, so for confidence intervals, we can get a precise critical value from the table for the standard normal distribution, or we can use a graphing calculator. So let's assume we want to do a 95% confidence interval. And in order to do that, we know that the critical value from the empirical rule would be z equals 2. Okay, so it would be z equals 2 from the empirical rule. However, the true value of z is not actually 2. The empirical rule is just a rule of thumb to help you estimate what those critical values would be. It's not the exact critical value. Now, if we want the exact critical value, which means a more precise, precise value rather than just 2, we would have to use the standard normal distribution table or a graphing calculator. So let's show you how to do that. If we want to do 95% confidence, well then when we set up the normal distribution, we would have 95% in the middle. So 95% of the area is in the middle. That's where we capture the true value, which means that the other 5% of the time we will not capture the true value. And that's going to be given in the tails. Now, and so we would do 95%, so we do 1 minus 0.95 is 5%. And then we would do 5% divided by 2 is going to give it to us for each tail. Okay? And that's how we would do it. Really as simple as that. Now, once we get that, we have a drawing, we have a picture of what we're going to do. Now we want to get the z-score from that area. So we're going to look it up in the standard normal distribution table, and we're going to look up an area of 0.0250. Okay? And then from that, we can get the z-score. All right? So here's a snapshot of how it looks like. If you're using the table, you look up an area of 0.0250, right? Which is the area that we calculated. And then from that, we can get the z-score from the table, which is negative 1.96. So therefore, that's a z-score, negative 1.96. Let me show you how this looks like in a real z-table. So here's what it would look like on the AP exam. You got your table for AP statistics. The table gives you the area to the left. We want the area to the left to be 0.025. So we're going to look up the area 0.025, okay? So 0.025, the closest value, we want to get as close to it as possible. So here we got a value of 0.025, right? And so from there, we can get the z-score right there, negative 1.9. And then, of course, we got to keep going up. So we're going to go up here. And there you go. We get negative 1.96. So you see that? That's how we get those values. All right. So now we showed you how to do it on the table. Let's show you with technology. So for technology, for the TI-84, you're going to need to use the inverse norm function. Okay. So you got inverse norm. I'll show you where to find that. You give them the area to the left, which is 0.025. You give them the mean, which is going to be 0. Remember, the mean of the standard normal distribution is 0, and the mean is 0, and the standard deviation is 1 when you're referring to z-scores. And this is going to give you your z-score. You're going to get negative 1.96, okay? All right, approximately when you calculate this. So let's show you how that looks like. Okay, so we're going to use the TI-84. And in order to do that, we're going to select second and then vars. And then we're going to go to inverse norm, option 3. Enter. We're going to type in the area, 0.025. We're going to use a mu of 0 and a standard deviation of 1, and we're doing the tail to the left. And that's going to give us a z-score of negative 1.96. You see that? Approximately so. All right, and that's how we calculate that. All right, so we showed you how to do that, but remember that there's symmetry. So it's not just negative 1.96. Now this value, of course, will be negative 1.96, but the other value will be positive 1.96, right? Because it's symmetric. So really, we have two z-scores, two critical values, positive 1.96 and negative 1.96, two critical values. So in general, the shaded area, this is the general formula. If you have any confidence interval, this is going to give you the area. Okay? So, for example, if I have a 92% confidence interval, then the area would be 1 minus 0.92, because 92 out of 100 is 0.92, right? Over 2. And so we get 0.08 divided by 2, which is 0.04. And so we would have the area being 0.04 in each tail. And we would have to look up the area 0.04400 in the table in order to get the z-score. Okay? And if we want to do it on the calculator, then to get the negative value, we would have to use the area on the left using this formula, which would be 0.04, the mean of 0, and the standard deviation of 1. And that will give us the negative z-score. All right, so I gave you two examples, one for 95% confidence, one for a 92%. We're going to look at another example as well, just to give you an idea. But first, let's go to the 95% confidence for the beads data. All right, so remember it's point estimate plus or minus margin of error. And the margin of error is point estimate. The margin of error is the critical value times the standard error. And remember that the standard error is given by this formula, right? And the point estimate for the beads example is p hat, right? All right, so we have p hat plus or minus z star times s p hat. P hat was 0.426 for the beads, the red beads. Now the z-score, we said that the z-star is 1.96. Remember we calculated that earlier from using the table? So we're going to use that. And then calculate the standard deviation, 0.426, 1 minus 0.426 over 251. This is going to give us a more accurate, a more precise confidence interval than just doing the 2. 0.426 plus or minus 0.061 when we calculate that. And that's going to give us 0.365 and 0.457. Oops, sorry, not 57, 87. I apologize. So 0.0487. And recall that we had earlier, when we didn't use 2, we had 0.364, 0.488. Okay? Which is not really that much different. However, if we want to be more precise, right, we would use 1.96 as opposed to using just 2. Okay? All right. All right, so let's look at example 2. According to a 2016 Pew Research Center, 73% of American adults have read a book in the previous 12 months. This estimate was based on a random sample of 1,520 American adults. Ignore that. Assume the conditions for inference are met. Determine the critical value for a 90% confidence interval. Okay? So again, we need to calculate the area. So the area is 1 minus 0.90 divided by 2, which is 0.10 divided by 2, which is 0.05. So we need to look up 0.0500 on the table to figure out what the approximate z star is going to be. Okay, so let's look that up, 0.0500. Here's the table. Let's look up as close to 0.05 as possible. So 0.05, all right, 0.05, oh, that's 00. We want 0.05. So 0.05 is between these two values right here, 0.0505, 0.0495. So you can pick either one of those because they're both the same distance from 0.05. However, I would probably just do an average of the two values. So either way, it's fine. You can do negative 1.6, negative 1.64, or negative 1.65, or halfway between those two, right? Which would be negative 1.6 or negative 1.645. Okay? Either one, however way you want to do it, and it's still going to work out. It's not going to be that much of a difference. But I like to be more precise with my stuff. So I'm going to say about negative 1.64 or negative 1.65 or negative 1.645, which I'm going to use that. Now remember, it's that's the z-score, but remember it's actually plus or minus, right? Because we actually have both negative and positive. All right, so if we were to use technology, it'd be 0.0500, or you don't have to put the 2 zeros there. You can if you want to. The mean of 0 is standard deviation of 1. We would get negative 1.645 for the z-score. So this is what I'm going to use. I'd rather use the technology value just to be more better, just to be more precise. So now let's construct a 90% confidence interval. So we're going to use the p hat is 0.73 plus or minus now we're going to use the z star, which is 1.645. Then we're going to use the standard deviation formula for the standard error formula, which is p hat times 1 minus p hat over n. And we have, for n, it was 1,520 Americans that were adults that were chosen. So we get 0.73 plus or minus. We calculate this. And that gives us 0.019. And then we can add and subtract to get the confidence interval, 0.711, 0.749 on the calculator. I'm actually going to show you how to get a confidence interval from a calculator right away using the TI. But for now, we're going to use the formula because we want to show you how to do both. All right, so if you were to graph this, remember it's 0, it goes by ones. And we want it to be 94% or 90% confidence. That means 5% in each tail. And we calculated the z-score to be negative 1.645 and positive 1.645. And each of these is 0.05, right? Each of these areas, 0.05. Okay? And then this is the 90% confidence here. All right, so interpret the interval from part B. So we are 90% confident that the interval from 0.711 to 0.749 captures P equals the true proportion of all American adults who have read a book in the previous 12 months. All right, so according to the Pew Research Center, many American adults have made money by selling something online. In a random sample of 4,579 American adults, 914 reported they earned money by selling something online in the previous year. Assume the conditions for inference are met. So you want to pause the video to see if you can calculate these, the critical value for a 98% confidence interval, construct a 98% confidence interval, and then want to interpret that confidence interval. All right, so hopefully you attempted that problem, paused the video, went back to see the context here, and attempted the example. Determine the critical value. So again, to find the area, you do 1 minus 0.98 over 2, which is 0.02 over 2, which is 0.0100. So we're going to look up 0.0100 on the table. Um, 0.01. Okay, so 0.0100 between here and here. This is the closest, so I would choose that. So that's going to be about negative 2.3, negative 2.33. Okay, that would be my critical value from the table. That would be the closest one. So Z star is approximately plus or minus 2.33. All right, using technology, you're going to do 0.02, the mean of 0, standard deviation of 1, and you would get a similar value. You're going to get 2.33 in decimal. Okay, so approximately negative 2.33. All right, so construct a 98% confidence interval for the proportion of all American adults who report having earned money by selling something online. Okay, so if we were to graph it, we would have 98% here. 0 goes by ones. And we got a value of negative 2.33. Value positive 2.33. And so then this is going to be 0.01. This is 0.01 for the area. All right, so we're going to calculate it. So we know that the p hat is 914 out of 4,579. And that's approximately 0.200. We have to calculate that before we do the confidence interval. So now let's do the confidence interval is p hat plus or minus the z-score, the critical value, times the standard deviation of p hat, which is 0.200, 1 minus that, out of 4,579 people. Okay, so if I calculate that, 0.200 plus or minus, if I do the margin of error part, that would give me 0.014 approximately. And then if I add and subtract, I get 0.186, comma, 0.214. That's my confidence interval right there. All right, so then we can interpret that and say we are 98% confident that the interval given here from 0.186 to 0.214 captures P equals the true proportion of all American adults who have earned money by selling something online in the previous year. All right, that takes care of that. So let's look at the learning target 3. So really, we're going to wrap this up with this last learning target. And really, we're going to do another confidence interval calculation, but we're going to do the full-on process. We're going to check the conditions. We're going to state the parameter we're trying to estimate. So we're going to do the entire thing. It's a 4-step process, okay? So the first process is to state the parameter you want to estimate and the confidence level. Second step, you want to plan. Identify the inference method you're using. What test are you doing? What interval are you doing? What conditions? Check the conditions. The next thing is to do. Actually perform the calculations. Step 4, then you're going to conclude, right? So what's your conclusion? Interpret the interval, right? All that stuff. So that's the 4-step process that they expect you to do on the AP exam if you have a confidence interval calculation that you need to do on the free response. All right. So example 3, a recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. Construct and interpret a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. All right, so let's do this 4-step process. State. What kind of confidence interval are we doing? Or what kind of thing are we doing? What kind of calculation? Well, we're stating that we're using a 95% confidence interval for P equals the true proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. Now, the plan is to do a 1-sample Z interval for P. Okay. After this, we're going to show you how to do all the calculations using the TI-84. But we're going to do the calculations, write them out first before we show you that. So we're doing a 1-sample Z interval for P. Then we got to list out our conditions. A random condition. We did have a random sample of 738 cell phone users. So check. 10%. Well, it is reasonable to assume 738 is less than 10% of all cell phone users. That's reasonable to assume. Then we're going to check the large counts, n times p hat. That's 738 users, and 170 admitted to running into something or someone while using their phone. That's going to be greater than or equal to 10. Then we have n times 1 minus p hat. Out of the 738, then that means that I could just do 1 minus that, which would be 568 people who did not admit to walking into someone or something while being on their phone. Those both pass with flying colors, so we can proceed with the do stage. So the do stage, remember, is the p hat, state the parameter that we're using, which is that, and which is equal to 0.230 approximately. Then we're going to do the confidence interval. Remember, it's p hat plus or minus, right? All that stuff. So, so p hat plus or minus the z-score. We need to figure out the z-score. So we're going to do the inverse norm of the area equals 0.025. Remember, we're using an area of 0.025 because it's a 5%, right? So area equals 1 minus 0.95 divided by 2, which is 0.025. Our mean is 0. Our standard deviation is 1. So we get negative 1.96. All right, so we're going to use that z-score over here. 1.96 times the square root. The standard error is going to be p hat times 1 minus p hat all over the sample size of 738. Do this on the calculator. We get 0.230 plus or minus a margin of error of 0.030. And the confidence interval is about 0.2 and 0.260. All right, so there's our confidence interval. So we are 95% confident that the interval from that to that, from this to that, equals P, the true proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. Remember, as an AP exam tip, you're expected to do the entire 4-step process. All right, so it's important that you understand that to get the full credit. All right, so here's the example. Pew Research Center reports on gamers and gaming estimated that 49% of U.S. adults play video games on a computer. This estimate was based on a random sample of 2001 U.S. adults. Construct and interpret a 95% confidence interval for the proportion of all adults, U.S. adults who play video games. So you pause the video, try this out. If you want to look at the state to help you out. And here's the plan, do, and if you need that to help you out. All right, so let's look at the first question. Hopefully you paused, tried it. So we got 95, so we wanted to do a 95% confidence interval for P equals the true proportion of all U.S. adults who play video games. We have 2001 adults in our sample for 9% for the P hat. Okay. So we're doing a one sample Z interval for P. The conditions, we have a random sample of 2001 U.S. adults. It is, for the 10% condition, it's reasonable to assume that 2001 is less than 10% of the entire U.S. adult population. And in the large counts condition, we're going to actually specify that. So we have N times P hat, excuse me. We have 2001 U.S. adults times about 49% or 0.49, okay? Remember, the P hat is about 49%, so 0.49. All right, so 0.49 is approximately 980, which is greater than or equal to 10. And then we do N times 1 minus P hat, which is 2001 times 1 minus that. It's approximately 1020 or 1021, which is greater than or equal to 10. All right. And for the do stage, we got that our Z star is 1.96. Again, we got that from before. We don't need all this. We just need to report our P hat is 0.49, and then we can calculate our confidence interval. So 0.49 plus or minus 1.96 times the square root, 0.49, 1 minus 0.49 over 2001. We calculate our margin of error first to get margin of error 0.022, and then we can calculate the rest of the confidence interval by adding or subtracting the margin of error. And we get this as our confidence interval. So we are 95% confident that the interval provided from 0.468 to 0.512 from our sample captures P equals the true proportion of all U.S. adults who play video games. All right, so now I'm going to show you how to use these results in order to calculate the confidence interval, okay? So we're going to show you how to do that, and we're going to use the calculator for that. Okay, go ahead and use the calculator for this part. Let's kind of move this off to the side. All right, so we got, we're going to hit stat. Okay, so we're going to hit stat, and then we're going to go to tests on the top right here. Then we're going to go down to one prop Z interval, okay? Those are tests, so we want to do a one prop Z interval. There you go. So one prop Z int. See that? I'm going to enter that. Then we're going to select our X. Our X is the number of successes. So we can use this to calculate. We could do 2001 times 0.49, and that will give us our number of successes. But remember, they don't like decimals for that, so we're going to just round it to 980. and then our number of their sample size, the total number of people from our samples 2001. We got a 95% confidence interval, and we can calculate that. And there you go. So we get 0.468-ish, see that? And 0.512-ish. So we can get the confidence interval from that. Really, really straightforward, and that's how we do it. All right, guys, that's going to do it for the video. Hope you found this useful and informative, and as usual, I'll see you in the next one.